Next, step 4. Let's assess the balance between the groups in the weighted cohort. In order to do this, and we have to do this in 2 stages, okay? In the first stage, what we do is using original data set, and we are going to just to do the summary table. Once this part gets executed, and then we go to the editor, EGR editor, okay? Then we need to hunt type these 3 lines, okay? And also this blue part, and we need to type SVY in 4 parts, okay? And once we all do this, and we highlight the whole thing and then execute it. So that will provide the baseline table with the stabilized ATE weighted data set. And as you see, SMD is much smaller. All variables have SMD less than 0.1, indicating good balance. So let's do this part in EGR. So go ahead to create the baseline table with the original data set, okay, and execute it. And then once this part get executed, and then go find this line, summary table of sample characteristics in easier editor, and then create the space here, and then type these 3 lines. What these 3 lines does is we are going to install package called survey, and then use survey design function, and so that we can use weighted data set. And then we have to find the first line, cat table line, and then type SVY here, and then also the same line and type SVY here. And then the 5th line, count table line, and type SVY again here, and also type SVY again here, 4 parts, right? And then highlight the whole thing and submit. And this will create baseline table with the weighted data set. Now, if you want to repeat this with ATT weight, what you have to do is switch and just replace this variable name with the name of variable you created for the ATT weight. So here I created baseline table also for ATT weight. And for ATT weight, TRIM dataset has 374 patients with catheterization, and so the similar number of patients will be used for those without catheterization. And so this ATT weight dataset also indicate a good fit because SMD is all less than 0.1. ATT weighted data. Patients with catheterizations are not similar to the original dataset. Percent of sepsis with catheterization is 23.8%, and here is 23%. The ATE weighted data said this becomes 17.6%. And also the age, mean age for catheterization group is 61.07, which is similar to the original data set. And albumin 2.98, APS 59.97, and these are very similar. And other 2 variables are also similar with the original data set. And so if you want to conduct analysis preserving as much of a population with treatment, and you may want to use ATT weighted data set. And although stabilized ATE weighted data sets a larger sample size for control group, so the outcome analysis might be more powerful to use ATE weighted data set. This is a comparison between ATT weighted sample and a stabilized ATE weighted sample. An ATT weighted sample preserves the entire population with treated patient, and then also the control group sample size will get equalized with the treated patient. And the stabilized ATE weight sample size will be kept similar to the original data set. So if you have a larger number of controls, and you might want to use AT weighted samples. The ATT weighted sample preserve almost the entire population of a treated patient. And then ATE weighted sample provide sort of the average effect of a subject who are included in analysis. For patients with a large PS, more responsive to the treatment, ATT weights more heavily for that. And ATE, on the other hand, has the same weight regardless of propensity score. In many clinical situations, physicians tend to treat patients who are likely to be more responsive using ATT, and the method weight them more. So the ATT may be better choice. And it is important to note that which cohort is to be used for the analysis need to be defined in advance before the analysis is done.